Okay, so here we have a target of being able to add or subtract fractions in mixed numbers. And we put add and subtract together because we'll be following the same rules whether it's adding or subtracting. Here's an example of 1/2 plus 2/3, and you may remember from 5th grade that you cannot add these fractions unless their denominators are the same. So we find what's called the least common denominator, the LCD, or you can say LCM, least common multiple. So what I like to do is just list out each denominator and list out the multiples. So the multiples of 2 are 2, 4, 6, 8, and so on. Multiples of 3, we want to start with the number itself, so 3, 6. Right away I can stop there because I see I have a match of 6. That would be our least common denominator. So now our second step, we want to take our original fractions in the question and turn them into an equivalent fraction with 6 as the denominator. Well, I'll just have to find the missing numerator. And we've learned this before. When you go from 2 to 6, that's 3 times bigger, right? Because 2 times 3 is 6. Therefore, you have to multiply the top by 3. 1 times 3 will be 3. So 1/2 is the same as 3/6. Now we're going to take 2/3, the other part of our question, and turn it into a fraction with 6 as a denominator. Using the do-do rule, when you go from 3 to 6, you're multiplying by 2, because 3 times 2 is 6. Whatever you do to the bottom, you must do to the top. In this case, timesing 2 by 2 will get us 4. So now really we're looking at adding 3/6 plus 4/6. Okay. Now that the denominators are the same, that will stay the same even in our answer, or sum. So it'll stay 6, and then we just add our numerators. 3 plus 4 is 7. And here's the thing, whenever you're left with an improper fraction, you never want to leave it like that. So we learned this before of how to turn an improper fraction into a mixed number. 1/6 fits inside 7. This is the same as saying 7 divided by 6. So 1/6 fits in there, with 1 left over as a remainder out of the original 6. So 7/6 as an improper fraction is the same as 1 and 1/6, and that would be your final answer of our original question of 1/2 plus 2/3. Just another example here. Some of you might be able to see right away the common denominator of 5 and 2. We have 1/5 plus 1/2. So if that's the case, you don't need to do the listing separately of multiples. You can just go ahead and change it. So I know that 10 is the least common denominator, so I can skip right to the step of making an equivalent fraction for each of the original fractions. Now with 10 as a denominator, I'll start with 1/5. That's the same thing as 2/10. 1/2 something over 10, so we have a match with our denominators so that we can add them. That would be 5 over 10, applying the same do-do rule. Going a little faster here, and we're just adding these. 2/10 plus 5/10. That's going to give you 7/10, and that cannot be simplified because there's not a factor of 7. There's also a factor of 10 other than 1. Okay, we also want to be comfortable with adding or subtracting mixed numbers. 3 and 7/9 plus 2 and 2/3. Same rules apply. We cannot add these fractions part of the mixed numbers until they are equivalent. So 7/9 and 2/3, I can see that 9 is the least common multiple. If you weren't sure of that, you could list them separately like we did with the first example. Now 7/9 already has 9 as a denominator. I don't need to change that. I just need to change the 2/3 of the 2 and 2/3. So 2/3 needs to have 9 as the denominator, so we can add it to the other one. Do-do rule, 3 times 3 will get us to 9. We do the same times 3 to the top, and we see that 2/3 is the same as 6/9. So now I'm just going to rewrite the question. I'll put a box around here to keep things a little organized. But 3 and 7/9, instead of writing 2 and 2/3, I just changed 2/3 to 2 and 6/9 so that we can have matching denominators. Now we can add. You'll notice I'm staying away from the whole numbers 3 and 2. I can add them separately at any time. I just wanted to work with the fractions first. It really doesn't matter which one you do first. But now let's just keep adding the fractions. 7/9 and 6/9. That's 13/9. Again, we have we have an improper fraction. Can't leave it like that. So we turn into 1 and 4 ninths because 1 9 fits inside 13 with 4 left over. But don't forget, we still have our 3 and our 2 as the whole numbers. So we're looking at 3 plus 2 plus 1 and 4 ninths. Really just add up the whole numbers as if they're just by themselves. 3 plus 2 plus 1, well, that's 6. And the fraction is still there, it's 4 ninths, okay? So your final answer is 6 and 4 ninths. There's another way to do this, so remember, pause the video at any point if you need to take these notes if you didn't get them the first go around. Okay, the other way to do this, you could change each mixed number into an improper fraction first. Okay, so 3 and 7 ninths is the same as 34 ninths. Okay, we've done this before, but 9 times 3 plus the numerator 7 and keep the denominator the same is converting mixed numbers into improper fractions. And 2 and 2/3 would be 8/3, okay? Again, we can't just add these fractions without a common denominator. So we already just learned that 9 was the common denominator from the first method. 9 is already in 34 ninths, so we'll just leave that the same, and we'll change 8/3 to some numerator over top of 9. 9 is 3 times bigger than 3, therefore do-do rule must do it to the top, and we get 24 ninths. So I'm really looking at adding 24 ninths, which is our equivalent form of 8/3, with 34 ninths. So I can just write that separately to try to be a little more organized. 34 ninths plus 24 ninths. Denominator stays the same, so I know it's going to be 9. Mental math, 58. Improper fraction, can't leave it like that. You're left with 6 wholes and 4 ninths. Same answer as we had before, just a different method to solve the same thing. So in this case, you can just pick with either method that works for you best. Okay, so here's a situation of 3 3 fractions. Same rules apply. You need a common denominator, and you can list them out separately. Count by 12s, count by 3s, count by 2s until you have a match. Well, I can see if I count by 3s, 3, 6, 9, 12, or it counts by 2s, 2, 4, 6, 8, 10, 12. 12 will be the common denominator. So I can leave 11 12ths as it is, since it already has 12. I'll just change each of these other fractions to some equivalent form with 12 as its denominator. Same thing as before, right? So we're looking at 11 12ths, which we did not change, minus, instead of 1/3, we made that 4 12ths. So I would write 4 12ths. Minus, instead of 1/2, we made that 6 12ths. Okay. Denominator, even with subtraction, stays the same of 12. And 11 minus 4 is 7, minus 6 is 1. So you're left with 1/12. Same rules apply, even when it's more than 2 fractions, 3 or more. Here's the steps that should be in your notes that we just did a few times. So take a moment to write them if you didn't get them the first time. And here is just one last thing you might see. We have a whole number minus a fraction. 2 methods for this one as well. 4 minus 2/13. Now we should know that any whole number can be written like a fraction over 1. So 4 as a whole number is the same as 4 over 1. And if you think about it, it's like 4 divided by 1, which is 4, because that fraction bar can read as division. But we can put it over 1 to help us do the addition or subtraction. So now you need a common denominator. You have 1 and 13. You need multiples of 13, multiples of 1. Now multiples of 1 are just counting by 1. So 1, 2, 3, 4, 5, 6. It goes on forever. So 13 will certainly be a multiple of 1. So we might as well just change 4 over 1 into some fraction equivalent with 13. Now 1 times 13 will get you 13. Multiply the top by 13. 4 times 13 will be 52. Now we're looking at 52 13ths minus 2 thirteenths, which is going to be 50 thirteenths. Okay, and again, don't leave it like that because the numerator is bigger than the denominator. So 3 thirteenths makes 39 with 11 left over out of 13. That's our mixed number. Pause and write this down if you haven't already from previous notes, because I want to show you the other method, which is a bit of a shortcut, but again, pick whichever method works best for you. Now, I'm just going to rewrite 4. 4 is our whole number, okay? But 4 can be rewritten like this, and I want to see if you can catch what I'm doing here. 4 is the same as 3 and 13 thirteenths. And we're still going to minus 2 thirteenths. Okay, think about it. 13 over 13 is 1 whole. So if you have 1 whole thing and 3 whole things, 1 plus 3 is our 4. Okay? But we want to write this new version of 1 as something that has a denominator of 13, because that's what we're trying to match with the other fraction. So I didn't just pick that out of a hat. It's very intentional. So when you're kind of subtracting 1 from 4, but then you're rewriting that 1 as a fraction over itself, or as a number over itself. Okay, and then you just do 13 minus 2, which is 11. Denominator stays the same. So really I'm just subtracting fraction minus fraction, and we still have 3 as our whole number because we have to rewrite that. So we're left with 3 and 11 thirteenths, which is the same thing we got through the other method. This is a bit of a shortcut, but it's a little bit of a mental leap in thinking how to get 4 and how to rewrite it to make it happen as a shortcut. Okay, so use whichever method is best for you.